Today we're looking at permutations. Now, a permutation is a ordered arrangement object, so we're counting the number of ways that we can order a set of objects. So, for example, how many ways can a race with 4 runners end? Now, often with permutations, a little bit of layout can help us again. What I'm going to do is I'm just going to draw in the 4 different positions. And I'm going to think how many of those runners could come first, or any of them could have come first. So there's 4 that could have come first. Now, one of those runners now won, so there's only 3 runners left who could become second. Similarly, 2 that could come third. The last position is going to be filled by the last, whoever's not already selected. So how many ways can the race end? Well, we've got a situation here where it's an and. So we need someone to win and someone to come second and to come third and come fourth. So we need to times all these. And 4 times 3 is 12, times 2 is 24, times 1 is 24. Now, a lot of the time when we do these sort of things, we end up multiplying a number by the number below it, by the number below it, by number below that. And we've got a way of writing that. So we write that as 4 factorial. You'll see on your calculator there's a button with an exclamation mark. It might be X exclamation mark, might be something else, I'm not sure on your calculators. And that will tell it what you need to do here is do 4 times 3 times 2 times 1. And if you put that in your calculator, you get 24. In general, if I say n factorial, what it's saying is to times n by 1 less than n by 1 less than that, which is n minus 2 times, and we keep going until we get to 1. So that's a factorial. Most factorials are only well defined for whole numbers. So asking what 1.5 factorial is kind of meaningless. However, a little odd thing that we need to know is that we say 0 factorial kind of doesn't fit into this pattern, but we say that equals 1. And there's a couple ways to think about that, and I can have to talk to you if you want about that later. So, now we're arranging our n objects, and we've got 24 if we had 4 objects. Now I could extend that if I had 8 runners. I'm not going to do 8 times 7 times 6 times whatever blah, but I could do 8 factorial, and we can put that in our calculator and work out what it equals. I'm not going to worry about that now. But what if we only cared about the first 3? We only care who's getting the gold medal, the silver medal, and the bronze medal. So here, I'm going to do my little box again. I care about the top 3. Well, the first place, there's 8 different runners. Second place is going to be 7 and 6. So what we see here is that we have a part of a factorial. We get 336. Now we could write this as a full factorial. We could write this as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But then we would have to then divide by 5 times 4 times 3 times 2 times 1 to cancel that out. And that's what our permutation button does on our calculator, which I'll explain in the next video.